the limit as x approaches -2 of a piecewise defined function. So as we look at this function, the function is equal to 3 when x is equal to -2. So we can go, okay, x is -2, y is 3. So we have that point, and then for the rest of the domain, the function's equal to -1. So down here, we have an open circle at -2 because it says x does not equal -2. And then we get a horizontal line for the rest of that. Okay? So the question is, what's the limit as x approaches -2? Now this is a common mistake that students make. A lot of students, or some students, they want to choose that as the limit. But that's really bad. That's only there to mess up calculus students. So you want to make sure that you, again, think about what are we approaching. If you're down here and you're approaching x equals -2, you're down here at -1. Same thing from this side. You're at -1. We're never going to reach -2. That's what a limit tells us. You're never going to get to this number here. So the answer to this question is -1. The function is, as we approach here, is -1. Okay. So, limits that fail to exist. If f of x approaches different values from the left and the right side, then that limit is going to fail to exist. So, that's important notation. On the free response part of the AP test, we're going to have to write it out like that to show, sometimes, to show that the limit does not exist, instead of just saying the limit does not exist. So this little minus up here that looks like an exponent, that means from the left side. And this little positive symbol here means from the right side. Okay, so we have another piecewise defined function here. And this one says that when x is greater than or equal to 1, the function is equal to 2. So that is equal to, so when x is equal to 1, y is equal to 2, and then when x is greater than 1. So that looks like this. And then the function equals 0 when x is less than 1. So that's going to be an open circle because there's no equal sign underneath the inequality. And then that's going to go to the left. Okay. So this has a slang term as a diving board function. Like here's the ground, you're walking up, and then you get on the diving board. Except that arrow goes on forever, so it's going to be a little awkward. You're going to have to dive off to the side. All right. So this question says, what's the limit as x approaches 1? So on the AP test, it's important to write this out. They're looking for this. If you don't write this out, you won't get the credit. So what we're going to show is that the limit is the limit of the function, which in this case, so it's saying from the left. So from the left side approaching 1, we're right here. So the function is actually equal to 0. You don't want to just write f of x because f of x is equal to two different things. So we need to keep that in mind. And then we want to check the limit as x approaches 1 from the right of, and when we're on the right of 1, the function equals 2. Now usually those are expressions with x's and such, but so that's what we have. So the limit here is equal, as x approaches -1, is 0, because it's a horizontal line, so it's that same number. It's a little bit awkward. And here, from the right, the limit as x approaches 1 from the right, the y value is 2. So that's 2. So these two things do not equal each other, so this limit does not exist. Okay, and it may seem awkward the first couple days as we're doing this, but it actually does get better. And if you look at the schedule, you'll notice that a lot of weeks we only have 1 or 2 lessons. At the beginning, we kind of need to go through this limit stuff fairly quickly, but please look at the schedule and notice that a lot of weeks there's only one lesson, and some weeks 2 lessons. This is pretty rare where we're going to do a bunch of lessons in a row. We have some work days built in where you can ask questions. And so that is that. Page 2. Another time that limits don't exist is if we have unbounded behavior. So what does that mean? If we look at, you notice this isn't highlighted, so it's not as big of a deal, but it's still, the highlighted stuff is absolutely necessary. The not highlighted stuff, it's just a little less important. So if we plug some values in here, we could do this on our calculator too, but if we type that in, we can just do that in our head. So 1 over the absolute value of -2, the absolute value of -2 is 2, so that's going to be 1/2. If we plug -1 in, that's going to be 1. 0 is undefined. 1 is 1, and 2 is 1/2. So if we plot some of those, that would be right here, right here. If we plugged in 1/2, 1 divided, or -1/2, then the absolute value -1/2 would be +1/2. 1 divided by 1/2, multiply by 2 over 2, and you get 2. So that would be 2. And then the absolute value, if you think about that, it's going to be the same on the other side. So we have, connecting the dots there. Okay, so as x approaches 0 from the left, the y values are approaching infinity. And as we approach 0 from the right, for x, the y values approach infinity also. So since they're both approaching positive infinity, we will say that the limit equals infinity, but that implies that the limit does not exist because there is no set specific number for infinity. So infinity is just a more descriptive way to say does not exist. If we say infinity, we know it does not exist. If we say it does not exist, we don't know why. But by saying infinity, we know, okay, because it's approaching infinity. So it's a little bit better. Over here on the side, this is just telling us that if we would have graphed this on our calculator and we would have typed that in y equals 1 over, we would need the absolute value of x. The way they do that on the T99 is you can go to catalog, and usually that's where it's at. It's in alphabetical order, and that's the first thing in the catalog. If you are somewhere else in the catalog, you can just push the letter A on your calculator here. So we can show you that real fast. So if we were graphing that, y equals 1 divided by, and now we want to put the absolute value of x. So what you can do is hit the catalog button right here, and you can see mine is at absolute value. Now if it's not at absolute value, if we type a letter, the letters are in silver here, except for x, y, z, and t, A, B, C. So let's say you wanted discriminant from the quadratic formula. So you might type the letter D. So if I hit the letter D, you notice it skips down to the D's. Well, I don't want that, so hopefully I can type A and it'll go back to the A's, and it did not. So what I need to do is change it to alpha mode. So alpha A, and now it switches back. So that's where the absolute value would be, so I could hit enter and then type X, and now if we graph that, it shows 1 over the absolute value of X. Okay? So down here. So another reason why a limit might not exist is if we have oscillating behavior. Oscillate, it goes back and forth. So I don't want to graph this. We've already looked at the calculator a couple times, but if you graph that, it looks something like this, and then it goes